All right, so this is the third time I'm doing this for you guys. The second time was great. I just never hit record on my camera. So we're going to do this again. So solving trig equations. This is page number. This is trig review. And I'm doing this because so many people struggled with this on the IA. Mostly with question number 15. Number 14 was also a little bit rough. So we're going to review this. So we're going to start with a question similar to question number 14 because that's the one that I felt like you were the most strong at. So let's start with 2 times the sine of x plus 1 equals 0. So if I was just going to break this down for you and really explain to you what exactly you're doing here, we're trying to find this missing piece, this x, which is the input of the sine function, which is going to be an angle. So the input of the sine function is always going to be an angle. So we're trying to find what angle. If we take the sine of an angle, multiply that by 2, and then add 1, our solution would be 0. Right? So what angle can I input here that if I simplify this whole expression, I would get an answer of 0? And I mean, I could start testing angles and substituting 30 degrees, 45 degrees, 60 degrees, and all these different angles here, just add and then multiply by 2 and add 1 and see which one will give me 0. But that would take me a long time because there's a lot of angles for me to test. So instead, what I'm going to do is, in order to solve this for this missing angle, I need to first isolate the sine of x. So similar to when we're doing square roots, right? We need to isolate the square root function before we can use the inverse of the square root. Right, we need to do the same thing with the sine function. So we need to isolate the sine function first before we can actually solve for this x value. And the way we're going to do that here is because this is a linear trig function, we can treat this the same way we would if this was 2p plus 1 equals 0 and solve for p, which here represents the sine of x. And we would just use inverse operations, right? We would know to subtract 1 and divide by 2. So if we would do that here, we're going to do the same thing here. Subtract 1, divide by 2. So now that I have my trig function isolated, I need to still find that angle. So what angle, if I take the sine of an angle, it'll give me -1/2. So when I think back to my unit circle, I'm thinking of all the things I remember about the sine of an angle. So I know that the sine of an angle represents the y-coordinate of that angle on the unit circle. And I know this is a -1/2, and when I think about a coordinate grid, I know that negative y-coordinates come from quadrants 3 and 4. And when I think about 1/2, or the sine of -1/2, I know that's going to be represented with a reference angle of 30 degrees. So I know for here that would be this one, which is 210, and over here would be this angle, which is 330 degrees. So that's what x is equal to. So the sine of 210 degrees, so if I put 210 here, I would get -1/2. The sine of 330 degrees is also -1/2. So that means that this x value is 210 degrees and 330 degrees. It could be either answer. And we're going to convert those to radians because we always do radians. So this would be 7 pi over 6 and 11 pi over 6. All right, so I get 2 answers. And if we don't know how I got those radians, think back to we take the angle and multiply by pi over 180 to get radians. So those are my 2 answers. So my answers are 7 pi over 6 and pi over 6. Right, my answer is not -1/2, right? That doesn't actually tell me what the angle is. That's the sine of the angle is equal to -1/2. So what is that angle? And that's what we're looking for. And we found it. So if I plug this into the equation for x, or this into the equation for x, and I would simplify to 0. So if I did the sine of 7 pi over 6, which is -1/2, -1/2 times 2, which would be -1, plus 1 will give me that 0. So, and if I substitute these in, they'll give me the correct answer that I'm looking for. So now let's go to, our next example, which is a little bit trickier. And this is the one that a lot more people had a problem with. So 2 sine squared x minus 3 sine of x plus 1 equals 0. Great, so how is this one different from the last one? Well, if I was going to guess, I would say that this one's different from the last one because now we have a squared trig function. Bam. And that's going to affect the way we solve this equation because now this is not linear, it's quadratic. And I know that with a quadratic function, I can't just use inverse operations when I have 3 terms like this. I need to actually factor this. But I don't want to factor this like this. So I'm going to factor this in a way that makes sense to me. And I'm going to do that by replacing the sign of x with a variable. And I'm going to use p. Minus 3p plus 1. The only catch is that before I give my final answer, I need to make sure that I substitute sign of x back into the equation once I've gotten p by itself. So once I've isolated p, I need to put the sign of x back into the function. So, because I'm still looking for this x, which still represents an angle. So now I'm going to factor this using my grouping method, which gives me 2 times 1, which is 2, negative 3. I need to multiply to a positive and add to a negative. The only way that's possible is with 2 negatives. So I know I have 2p squared, that comes down exactly the same. This is going to be split up into negative 2p minus p, because that'll give me negative 3p, and then plus 1 comes down and equals 0. I group, I get 2p, p minus 1, negative 1, p minus 1. P minus 1 is what they have in common, so p minus 1 here. 2p minus 1 is my other factor, equals 0. P minus 1 equals 0. 2p minus 1 equals 0. P equals 1. P equals 1/2. Now I have p by itself. This is the point now where I put sign back, or sign of x back. So now instead of p, it's the sign of x is equal to 1. And instead of p, it's the sign of x is equal to 1/2. So now I do the same thing I did in the previous example. The sign of what angle is 1? So if I go back to my unit circle, it's a positive y coordinate. Where is my positive y coordinate 1? Right here, at 90 degrees. So x is 90 degrees, which I know in radians is pi over 2. Same thing over here, but what angle is going to give me, the sign of what angle is going to be 1/2. I think back to my unit circle. The sign is the y coordinate. It's a positive y coordinate, so that's quadrants 1 and 2. 1/2 represents 30 degrees, so 30 degrees. 30 degrees. Over here is 150 degrees, because that's 30 degrees from 180. This is 30 degrees from 0. And that gives me my 2 angles, which is x equals 150 degrees and 30 degrees. So I know 150 is 5 pi over 6. And 30 is pi over 6. So basically what this means now is that this is my x value. So that means that if I plug any one of these into this original function for x, and I simplified it completely, I would get 0 as my outcome. So I can do that on a calculator to check my answer. I can pretty much do that using any tool that I'm comfortable with. But if I plug pi over 2, 5 pi over 6, or pi over 6 into this equation for x and simplified it, it would simplify to 0. And if you don't believe me, try it out. But I don't have time to do that for you. So we're going to try one more example because this is so much fun. I'm having the time of my life. So let's try example 3. Just to switch this up a little bit, let's go with something that I don't think we've done yet, but still doable for you. So we're just going to use your recall knowledge. Great, so I'm looking at this example and I'm thinking, wow, how is this example different from the other 2 examples? Well, I can see that it reminds me of the first example because in the first example on the previous page, I had 2 times the sign of x plus 1. So I was multiplying and adding. And over here, I'm also multiplying and adding. So multiplying 4 or subtracting and subtracting 3, right? But then it's similar to the other one because it's also the sign squared. So it's a quadratic, but it only has 2 terms. So what would be the easiest way for me to solve this? Well, because I only have 2 terms instead of 3, and there's no greatest common factor, and it's not a difference of perfect squares, I'm thinking that I might be able to use inverse operations here. So I'm going to try to do that. And I'm going to isolate the sine squared of x. But instead of sine squared of x, I'm going to replace it with a variable. Because anytime I see that sine squared, it just really throws me off. So I'm going to do 4p squared minus 3 equals 0. Just got to remember to make sure to replace that sine back once I've isolated p. So now I'm going to use inverse operations here because I only have 2 terms. 3 is not a perfect square, so we're not doing a difference of perfect squares. And there's no greatest common factor. So I'm going to use inverse operations. So I'm going to add 3 to both sides first. And then I'm going to divide by 4. And then now to undo p squared. Square, the opposite of square is square root. I'm going to square root the whole thing. And when I do that, actually what that does is gives me 2 answers. It gives me a positive and a negative of the same number. So it gives me a positive square root of 3 over square root of 4, which is 2, and a negative square root of 3 over the square root of 4, which is 2. So I get 2 answers. So I get p equals square root of 3 over 2, and p equals negative square root of 3 over 2. But because I've isolated p, I need to now replace the sign of p back, or the sign of x back, where p is. Now I need to find the angles. What angle, sine of what angle is square root of 3 over 2, and the sine of what angle is negative square root of 3 over 2. Let's start over here, unit circle. Sine is y. So I'm looking for a positive y, which is here and here, 1 and 2. Sine square root of 3 over 2, that is 60 degrees. So 60 over here, and then 60 from 80 is 120. I did have to think about that for a second. So 60 degrees for x and 120 degrees for x, which is pi over 3. And 2 pi over 3. So now the sine of x is equal to negative square root of 3 over 2. If I think the same thing, my unit circle, sine is y, it's negative. So that means it's in quadrants 3 and 4. Once again, because it's square root of 3 over 2 and it's sine, it's still at 60 degree reference angle. So 60 degrees here, 60 degrees here. So 60 degrees from 300 is 60 degrees from 360 is 300 degrees. And 60 degrees from 180 and going in that direction is 240. So I know that x is going to be 240 degrees and 300 degrees, which I think back to the radians, this is 4 pi over 3, and then this is 7 pi over 3. No, 5 pi over 3. And there's a cat. So it's 4 pi over 3 and 5 pi over 3. And those are my final answers. So essentially what this means is that if I plug any one of these angles, which is 60, 120, 240, and 300 degrees, in for x into this equation, and I simplify it, no matter which one I plug in, it's going to give me an answer of 0. And if you don't believe me, once again, you can just substitute it or plug it into your calculator or try it by hand, and you will get 0 no matter which one you plug into the equation. So there's 3 different types of equations you can get and you can solve, and now you have all this lovely information to refer back to, and that's pretty much it. So I'm glad we went over this and reviewed. See you in a minute. Oops.